Bonjour. In this video, I will showcase my third entry for the parametric object challenge. And this entry will be a boom lift. A boom lift is simply a machine that allows operator to operate in heights. So for example, if I need to install facade panels, then this is the type of product that I will be using to do so safely. So this is the machine in 3D, and it also has dedicated 2D view as well. That is a bit more simplified because in plan view we do not need more than what we see right now. For this subject, the real challenge was all the trigonometry because the arm is fully deployable. If I use here the dynamic hotspot, we can see that we have the full kinematics of the arm that are created accurately to the reality of that product. Here I can also move this arm as well, and we'll see we have the two pistons that are moving also accordingly. We can also, and here it's a mere translation, but still we can extend that arm, and we can also change the angle of the jib here, so very high or very low. We also have the ability to rotate the machine. Here I can rotate the base and then everything will follow. For example, because the machine operates at 360 degrees, so it can be, for example, backward. This is not an issue at all. And I can also rotate the basket here. So minus 90 and plus 90 degree, the way it is needed to be. So really, this is all the trigonometry and the accuracy of the kinematics were really the big challenge for this object, and I am quite proud on how it turned out because it looked quite nice when we manipulate the object with the dynamic hotspots. But doing so in 3D is quite fun, but we could also do it with the option panel. So in this option panel, we can see all the dimensions that are parametric, and we can also see some technical options that are more visual helps than anything else. We also have some live dimensioning of the object, and two information that are really important: the current offset, which is the horizontal dimension from the rotation center of the base to the center of the basket, and the current height, which is the vertical dimension from the floor to the platform of the basket. Those dimensions, are updated live, obviously. So if here I change the offset, I will also have a change of this info here. So here I can see that according to the reality of the object, I have minimum and maximum sizes that needs to be respected, otherwise it's not possible to do so. If I want to have here the arm fully horizontal and straight here, then I need to put all the angle and rotation at 0, and when I apply, then everything is proper. So really here, except for this big challenge to have the proper trigonometry everywhere it needs to be, this is all that we can do with this object here. And we also have some options that are quite interesting when using this machine. Here we can see the turn radius, which will allow me to know visually the diameter that is needed to do a half turn or full turn, for example. We also here have the work area, which is basically the space in 3D in which the operator can operate safely. So basically it is 50 centimeters outward of the basket and from the platform 2 meters high. And this is the area in which and the volume in which the operator is deemed safe. Anything more than that is deemed unsafe. And we also have, as a third technical option, the size chart. The size chart is really all the possibility that the machine can do when it comes to what it can reach. So for example, here, if I extend the arm that way, as it is fully horizontal, we will see that my work area will be fully aligned here, as it is the maximum offset. If I do here the same with heights, and I extend fully both arms and angles, we will see that now the work area is aligned to its top. So that's why, if for example I am lazy and I don't want to deploy the machine fully, I can just use the size chart, for example, and that will be enough. So here, for example, I put everything at 0 and at the minimum value, and here the size chart will not change, obviously. It will stay that way. So that is all in 3D. What we will see now is the same in 2D as well. So in 2D here, what I can do is that I can rotate the machine and the basket as well. I can also extend the arm, which extend according to the angle. Here the angle is at 0, so obviously the translation is simple. But if there is an angle, for example here I put 45, we will see here that the translation is a bit slower because it takes into account the angle as well. So when it comes to the visual help, we see the same. So the turn radius is a bit more complete here. We have the outer radius that is fully drawn, so that way when I am in a side plane or simply in plain view, if I have some wall like that, well, I know now that I cannot maneuver this machine. I need this machine to be a bit further from the walls in order to properly turn. For the work area, well, it's just simply a rectangle. And for the size chart, it's a bit different because we simply have 3 circles. The main circle is the max work area. Here, because this is really the maximum reach that the machine can do. So very simply, if I see a point that I want to reach that is within this circle, then that means that in this very position, then the machine will be able to reach it. You know, it's really a clear indication. I do not need to go see in 3D. Here I can see directly. And we also have the current work area and current offset. The current offset is obviously this value here, and the current work area is simply the work area according to the position of the basket right now. This one here is obviously will change obviously according to the extension of the arm and also the different angle of the jib and here of that arm as well. That is all for this subject. I hope that you liked it and that the video was clear enough. And I also hope that my other entries for this challenge will be to your liking as well. Bye!